All right, 2.2b. You guys are going to need your calculators for this one, so why don't you pause it real quick and go get your calculator. All right, and on your sheet, there's a Roman numeral 1 that says find the average rate of change of a function. We are going to skip that one, so you can put a little work in that space there, because we're not going to use that problem. We're going to start at Roman numeral 2, where it says a coin is dropped from the Sears Tower. All right, so everything today is based on this idea of a position function. And this is the same position function you are going to start with for every single problem. So negative 16t plus v naught of t plus s naught. So it's really a v sub 0 and an s sub 0. This stands for your initial velocity, so the starting velocity. And the s is your starting height. All right, so let's look at this first problem. A coin is dropped from the Sears Tower, which is 1,241 feet high. Okay, so if the coin is sitting at the top of the Sears Tower, that means the initial velocity of the coin is 0. And so that position function is always s sub t. We're going to keep that negative 16t squared. The velocity is 0, so it wipes out that middle term, and the initial height is 1241. All right, there's your position function. The velocity function is really just the derivative of the position function. So if I take the derivative of this using your power down rule, I'm going to do s prime of t. Now it's a negative, if I power that down, becomes negative 32 t to the first. That 1241 gets eliminated. So that's it. There's your velocity function. Now your acceleration function is just an added little part here. It's really, so I put 2 primes there. I take the derivative of the velocity. So your acceleration in physics, it could be at, 9.8 or 32. So that's where it comes from. It comes from the derivative of your velocity function, because if I take the derivative of this, I get just negative 32. Okay, so we're going to use these ideas to now answer the rest of that worksheet. So B says find the average velocity. I want you to underline that phrase, average velocity. Average velocity just means, just find the regular slope. So I want the slope, and we're going to use the position function. Okay, so I'm going to use the position function for the slope between the points t equals 1 and t equals 2. So really then if I'm using slope, all I need is a coordinate. So 1, and I'm going to plug 1 into this position function here. So if you do a negative 16 times 1 squared plus 1241, plug that in your calculator, I got 1225. And then you're going to take 2, you're going to plug that in your position function. So it's negative 16 times 4 plus 1241, and I got 1177. So now all I'm doing is algebra. I'm just finding the slope between those 2 points. So 1177 minus 1225 over 2 minus 1, I got a negative 48. So all that means is if the coin is going down after 1 second and then after 2 seconds, in between there, between 1 and 2 seconds, the coin is traveling at an average speed of 48 feet per second. It's negative because the coin is going down. All right, let's move to C. And in C, I want you to circle, underline, highlight the phrase instantaneous velocity. All right, instantaneous velocity. That means we need the derivative, which means we are going to use the velocity function. So my velocity function, remember, was this. But now I want it in between 1, or when t is 1 and when t is 2. So it's really just 2 separate problems. Let's find it when t equals 1 and when t equals 2. So in part B, when it was the average velocity, you're just finding the slope between the two. Now I want, how fast is that coin traveling at exactly the moment t is 1? Well, and t is 1. If I plug 1 into that velocity function, I get negative 32 feet per second. At 2, if I put a 2 in here, I get a negative 64 feet per second. Which makes sense because the previous problem was the average of these two. So if I take the average of these two, it gets me a negative 48. So the average is the time traveled. Instantaneous is at that moment. Next one, D, says, find the time required for the coin to hit the ground. All right, well, if it's hitting the ground, the height is 0. And if it's hitting the ground, I want to use the position function. So I'm going to use that position function from the beginning, negative 16 squared plus 1241. But now the coin hit the ground. So I'm going to set that equal to 0 because the height of the ground is now at 0. All right, go through with your calculator and take a second and solve that. Now realize it's a plus or minus, right? So if it's plus or minus, we're not going to have a negative amount of time. So you can toss the negative answer. I got that it takes about 8.81 seconds. E, last one for this type of problem. Find the velocity of the coin just prior to hitting the ground. Okay, so here we want to use the velocity function. So that velocity function was negative 32t. But right before it hit the ground, well, it took 8.81 seconds for it to hit the ground. So right before it hit the ground, it's going to be right around, again, that 8.81 seconds. So negative 32 times 8.81. All I'm doing is taking this answer from part D and plugging it into the velocity function. So get your calculators. Negative 32 times 8.81. I got that coin was moving very, very fast at negative 281.92 feet per second. Again, it's negative because the coin was traveling down. All right, so that's all the position function type questions. The ones in your homework are going to match up very closely to A through E. All right, your last one is that one on the Roman numeral 3. You're going to have a couple of those problems, and they're just different. So I just want to make sure we talk about them in this section. All right, so I want the rate of change of the volume of a cube when S equals 4. Okay, so if I want the volume of a cube, you are going to have to do some work on some of the problems. They will give you the formula, and some they don't. So in a cube, it's length times width times height, but in a cube, all the sides are the same. So I'm going to say that the volume is just side cubed. So now I could say that my formula is V of S is equal to side cubed. And I want it when S is 4. All right, well again, do not plug this 4 in here right away. You have to take the derivative first. So V prime of S, power down. Now I can take the 4 and plug that in there. So we're going to say that that volume is changing. At that moment when the side is 4, the volume is 16 times 3 is 48. And we're going to put centimeters cubed because we are dealing with volume. The units were supposed to be centimeters. I think I forgot to write centimeters after that side equals 4. It should have been here. I just missed that. All right, that's it for section 2.2. Hopefully you're doing okay, and we'll talk to you guys soon.